All right, so now we're going to talk about 2.2. In 2.2, we're going to talk about conditional statements. Conditional statements, okay? So in the top portion of page 81, there's a statement that says, if a butterfly has a curved back line on its hind wing, then it is a viceroy. Okay? So anything that has an if, then is a conditional statement. So if, then, right? So in other words, so that's what we call a conditional statement. So if you go in the middle of that page, it shows you what the definition of a conditional statement is. A conditional statement is a statement that can be written in the form of if P, then Q. So if P, then Q. Okay, so this is a conditional statement. If, so you read this as if P, then Q. Okay, so if P, this portion here is called the hypothesis. This is the hypothesis. And this here is the conclusion, right? If you have a curved black line on the hind wing, then it is a viceroy, okay? If, then, all right, okay? So that's how a conditional statement is constructed, okay? So let's go to example 1 and see if we can identify these parts. A, if a butterfly has a curved black line on its hind wing, then it's a viceroy. We just talked about this. The hypothesis is a butterfly has a curved black line on its hind wing. Conclusion is the butterfly is a viceroy. Okay. A number is an integer if it is a natural number. Okay. So the if part would be what? If a number is an integer, no. So the if part here is what? If it is a natural number. If it is a natural number is the hypothesis. The conclusion is the number is an integer. So you have to be careful here to make sure that not always the first part is the hypothesis and the last part is the conclusion, okay? So it's because in this one it says a number is an integer if it is a natural number, okay? So it kind of throw you off there. Okay, so you always have to kind of read and find out which part is the if part and which part is the conclusion. Okay. So example number 2, writing a conditional statement. Write a conditional statement for each of the following. The midpoint of M of a segment bisects the segment. The midpoint M of a, what? Okay. The midpoint M of a segment bisects the segment, okay? So what is the conditional here? The condition is what? If M is the midpoint of a segment, then it is the midpoint, then it is the M bisects the segment, okay? So again, if M is the midpoint of the segment, then it bisects the segment. Now you have to be also careful that whenever you see a statement, okay, does not have to be necessarily true, okay? It can make no sense whatsoever, but you can still have an hypothesis and a conclusion, okay? The truth and the false value, okay, whether it's true or not, or false, is something that's totally separate to what we're talking about here, okay? B, the inner oval represents the hypothesis and the outer oval represents the conclusion, okay? So, okay, here we go. So conditional. If an animal is a tarantula, then it is a spider, okay? That's what they're saying there, okay? It's because you have the spider, you have the spiders here, and then you have the tarantulas here. Okay, so if, okay, what does it say? If an animal is a tarantula, then it is a spider. Makes sense, right? Because all tarantulas must be a spider. Okay. Now, in example 3, now we'll talk about the true or false of the statements. Okay. Now we're going to kind of dig in and find out whether it's true or not, right? So in example number 3, I have, if today is Sunday, then tomorrow is Monday. Okay? So is that true? Is that a true statement? If today is Sunday, then tomorrow is Monday. Well, yes. So it is true, right? So the conditional is true. Okay, the statement itself, conditional statement is true. Okay? B, if an angle is obtuse, then it has a measure of 100. So in B, it says if angle is obtuse, then it is 100 degrees. So is this true? This is not true, right? Just because an angle is obtuse does not mean it's 100 degrees, right? It could be 120, it could be 150, it could be 140, right? Okay, so this is false, right? If you switch these around, it would have been true, right? If the angle is 100 degrees, then it's an obtuse angle. That would have been true, right? Okay. And we'll talk about switching these around really shortly here. Okay. C, in C we have, if an odd number is divided by 2, then 8 is a perfect square. Okay. So is this true? If an odd number is divisible by 2, then 8 is a perfect square, okay? So the hypothesis is false, right? What is the hypothesis here? Odd number is divisible by 2. An odd number is not divisible by 2, right? And what about the conclusion? 8 is a perfect square. 8 is not a perfect square. 9 is a perfect square, right? 8 is not a perfect square. So the hypothesis and the conclusion are both incorrect here, right? They're both false. Okay. However, wait a minute. The conditional is true because the hypothesis is false. Okay, so where are we at? If the hypothesis is false, the conditional statement is true, regardless of the truth value of the conclusion. So once the hypothesis is false, it doesn't really matter what happens in the conclusion, okay? That means the truth value, so the statement is true. Okay. All right. So let's go down the bottom of there. It says negation. The negation of statement P is not P. So remember we talked about, okay, let's make a new conditional statement. Let's make a conditional statement that if you are in Mr. On's geometry class, okay, then you are smart. Okay, so if you are in my classroom, then you are smart. So the hypothesis here is what? The hypothesis is that if you are in my classroom, right? If you are in Mr. On's geometry class, right? And then the conclusion would be then you are smart, okay? So a negation is the opposite or the negative of one of the statements. So the opposite of the hypothesis or the negation of the hypothesis here would be what? If you are not in Mr. On's geometry. So this would be right now, if this is the statement right here, P, the hypothesis is you are in Mr. On's geometry class. The conclusion is that you are smart. So the negation is indicated like this. And this would be what? If you are not in Mr. On's geometry class, okay, and the negation of this, of the conclusion would be what? Then you are not smart, okay? So if you go to top of page 83, there are a bunch of those, okay? So there are 3 different related conditionals. So the initial condition was, if you are in Mr. On's geometry class, then you are smart. Okay, then the next one is the converse. The converse is what? The converse is Q, if Q, then P. So the converse would be, if you are in Mr. On, you are smart. P would be, then you are in Mr. On's geometry class. Okay, that would be the converse. The inverse is that if you are not in Mr. On's classroom geometry class, then you are not smart. And last but not least is the contrapositive. Contrapositive. And that's the only one that's left, right? The only one that's left is that if you are not in Mr. On, if you are not smart, then you are not in Mr. On's classroom. Okay? So this is the original conditional statement. Then you have the converse of that, the inverse of that, and the contrapositive of that, okay? This will definitely be on the test. You have to be able to, if I give you a statement, you have to be able to state the converse, the inverse, and the contrapositive, okay? All right. So let's go back to our initial, if you have a black line in the hind wings, then you're a viceroy, okay? Or, no, never mind, it's a different one, okay? If an insect is a butterfly, then you have 4 wings. So if an S, so P would be the hypothesis, if it is a butterfly, then the conclusion is, then it has 4 wings. It has 4 wings, okay? So the converse would be what? The converse would be, if it has 4 wings, then it is a butterfly. That's the converse. The inverse would be, if it is not a butterfly, then it does not have 4 wings, because it's a negation of both. Okay. The contrapositive is that if it does not have 4 wings, then it is not a butterfly. Okay. All right. Everybody get that? Okay. In the example above, the conditional statement and its contrapositive are both true. Okay, so in other words, this is true and this is true. This was not true and this was not true. So if it has 4 wings, then it is a butterfly. It's not true because it could be a moth, it can be whatever, right? The other one is, if it is not a butterfly, then it does not have 4 wings. Okay. Is that true or not? I do not know. A moth is, so, okay, they bring up the moth also on this one too. A moth is not a butterfly, but it has 4 wings, okay? So this is also is not true, okay? So false, false, true, and true, okay? So blah, 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 blah. What does it say on the bottom, okay? Okay. In the example above, the conditional statement and its contrapositive are both true. The converse and inverse are both false. Related conditional statements have the same truth value are called logically equivalent statements. Okay, logically equivalent statements, all right? A conditional and its contrapositive are logically equivalent. So they are, and so are the converse or the inverse. In other words, if this is true, this is true. If this is true, this is true. If this is false, then the contrapositive has to be false. If this is true, this has to be true. So the truth value, so if this is true, then this is true. Or if this is true, if the converse is true, then the inverse is true. Okay? Right? Okay, I know this was kind of hard and it's kind of new, all right? But that is the end of the conditional statement. So this is often pretty confusing for you guys. So let's go ahead and start working on the homework and then we'll go from there. Are there any questions on this? Does anybody have any questions? Or maybe we'll get some questions as we do the homework. All right.